Hello everyone. In this video, I want to show you how you can set up a development environment on your local machine where you run Python code in a Docker container. Now, there's a few reasons why you might consider doing this, and the number one reason is for reproducibility. If you run a container that's based on a commonly available image or an image that you've created and can distribute with the world, then other people can reproduce your code results as if they were running their code exactly in your environment. Now, if you're new to Docker, no worries. There is kind of a learning curve, I would say, because immediately when you start working with Docker and start seeing some of the terms, you're like, oh, okay, so it's like a virtual machine. And it is like a virtual machine, but there are some key differences that make a Docker container not a virtual machine. So what I hope to do in this video is just provide an introduction to getting Docker installed on your machine and starting to develop Python code in a reproducible environment called a Docker container. Along the way, I hope that you pick up some key terms associated with Docker and see how it is like a virtual machine, but still different from a virtual machine, and see how you might use it in your future development. All right, so let's get started. The first thing that you're going to want to do is download Docker Desktop. So you can Google download Docker Desktop, and it'll bring you to a page that looks like this, docker.com/product/docker-desktop. Now you can see that Docker is cross-platform, so choose the download for your operating system. So I'm running on a Mac right now, so I'm going to download for Mac. All right, so we'll need to save this somewhere. I'm going to save this in my downloads folder. This is the installer for Mac, docker.dmg. Now this looks like it's about a 550 meg file, so looks like I've got about 40 seconds left of my download. While this is downloading, I will equate what we're doing to a little bit of your background you might have in running virtual machines. So with a virtual machine, you have a host operating system, which in my case is Mac, and you have a guest operating system, which might be Linux or Windows or Ubuntu or something like this. So you download something like VirtualBox or VMware or QEMU or some kind of program that will run on your host operating system so you can run a guest operating system. So essentially what we're doing is downloading the container version of VirtualBox, okay? We are not going to be running full-blown virtual machines though. We're going to be running Docker containers, which are much lighter weight and don't include a full-blown guest operating system like a virtual machine. All right, that was enough talking to cover my download here. I'm going to click docker.dmg and I'm going to run the installer. If you're on another operating system, make sure that you run that installer. If you can't simply launch it from your web browser, then go to that folder where you downloaded it and try and launch it from there. All right, looks like we've got a little bit more time to talk about Docker while it's essentially extracting and preparing the Docker installer. So think back to virtual machines and how you have a virtual machine disk image, right? Usually like an ISO image, ISO, that represents essentially the image for the operating system or a definition for an operating system that you could use in order to run that operating system, okay? So you typically launch something like VirtualBox, you load in that disk image or that ISO, and it extracts that image and launches it as a running virtual operating system. Now, we would call that an image, and then when we run that image, we would call it a virtual machine. Now, with Docker, we have images as well. These are static files that represent, oh, here we go, drag and drop. These are static files that represent our application image, okay? So we're not actually essentially packaging up and using an image for a full-blown operating system. we're packaging up the entire tech stack and dependencies for an application or a set of applications. Okay, that's what makes Docker images much more lightweight than virtual machine images. It's really everything you need to run an application versus everything you need to run an operating system. All right, so I'm essentially copying Docker into my applications folder. This is 1.5 gigs, so we'll watch this progress bar, but it'll take a little bit of time. All right, back to the virtual machine analogy. So when your virtual machine is running your guest operating system, you can install additional programs, you can save files to the virtual file system, etc. Well, with a Docker container, which is an instance, a running instance of a Docker image, you can do the same thing. You can install additional programs. You can modify the file system. So if you delete that container, then you essentially only delete the instance. The image will still be there, and you can create another container running from that instance. So it looks like I've successfully installed Docker. So I'm going to launch Docker Desktop now. So how you do this is dependent on your operating system. So I'm going to simply hit Command Spacebar to bring up my searchlight. You can also do this in the upper right-hand corner here. All right, so here it is, and I'm going to type in Docker, and it looks like docker.app. I can launch it. If you're on Windows, you probably have a shortcut on your desktop, or you can simply go to your Start menu and then search for Docker. All right, it says Docker Desktop needs privileged access to install its networking components and links to the Docker apps. You will be asked for your password. I'll hit OK, and I'll type my password in here. If you're on a Windows machine, during the install, you might be prompted to enable WSL2 features. Make sure you keep that box checked. You might be prompted at this time to install those additional features. All right, so now at the top of my taskbar here, I've got a little entry here for Docker Desktop. It says Docker Desktop is starting. I'll click on Dashboard to see the state of things. All right, perfect. And you can see on the left side, we've got two entries here, containers/apps and images. So while we were installing Docker, I provided hopefully somewhat of a clear overview of the difference between an image and a container. So an image is essentially a static definition for your app and its tech stack. And then a container is an instance of that image. So you can think about this in terms of object-oriented programming, right? The image is like your class definition, and the container is like an object. And what's cool about these containers is you can start and stop them. Kind of similar to how with objects you can serialize them to disk and then deserialize them later if you want to kind of reinflate them and use them at runtime. What we want to do now is we want to create a Docker container running from a Docker image that we fetch from the web. The Docker image that I want to fetch from the web is called Anaconda 3. If you've heard of Anaconda 3 before, you'll know that Anaconda 3 is a Python 3 distribution. In fact, it's the most common Python distribution for data science and scientific computing. It contains a lot of really great libraries like NumPy, SciPy, Pandas, Matplotlib, Seaborn, scikit-learn, etc. So I'm going to Google, let's do Anaconda 3 Docker image. And the first hit here is for Docker Hub. So Docker Hub is essentially a site that hosts Docker images. So here's Continuum.io. This is the organization that maintains the Anaconda 3 Python distribution /Anaconda 3. So this is a Docker container with a bootstrap installation of Anaconda based on Python 3.5 that is ready to use. All right, so here under usage, we've got some commands for Docker that we can use to download and run this image. All right, so we can follow these instructions here, but I've got my own instructions that include some flags for the run command that are really helpful, I think, when getting started working with Docker. So I'm going to flip over to my own notes here, but I did want to show you the source of the Docker image we're going to be downloading. All right, so I've got instructions here called create Anaconda 3 container from an image. And so I've got this Docker command here that is meant to be run at the command line, so terminal on Mac Linux or command prompt on Windows. And you will have to grab a different command depending on what operating system you're running. The reason why is because I've set it up so that it uses this little environment variable, pwd, which just grabs the present working directory or the current working directory that you're running your terminal in. But on Windows, you'll need to use %cd% instead of $pwd. All right, so here's what we're gonna do. Let's copy this command and then head over to your terminal or your command prompt. And let's make a directory. And this directory is going to essentially be mapped to the home directory of our container when it's running. So I'm going to make a directory. I'm going to call it Anaconda 3 temp. All cd into Anaconda 3 temp. And then I'm going to paste this command here. So let's go through the command. So docker run is going to attempt to run this image right here, continuum.io/anaconda3:2020.11. So this 2020.11, this is the particular tag or the particular release of this image that we want to run. So let me show you where that 2020.11 comes from. So if you go back to our continuum.io/anaconda3 page on Docker Hub, okay, here's the overview. You click on tags and you'll see that there are a lot of different releases of this particular image. And to uniquely identify them, they are tagged. So the latest release always has the tag latest. And you can see that this latest release was last pushed to Docker Hub a month ago, December 1st at 2:05 p.m. If I look at the next tag, 2020.11, okay, last pushed a month ago, it is actually the same image. So the latest tag always refers to the most recently pushed image. And so here, that corresponds to this image, the one with tag 2020.11. So rather than just grab latest, we're going to grab 2020.11 so that we all have the exact same one, right? Because in a few months, there might be another latest, right? But if we grab that one, it'll have different versions of Python libraries and whatnot than the 2020.11. So let's grab 2020.11 and we will use this one. All right, so Docker run, continuum/anaconda3 tag 2020.11. Okay, what's all these extra flags in between here? So the -i-t, this is going to launch an interactive terminal that is essentially a bash shell connected to our running container where we can issue commands once the container has been launched. So that's really helpful to immediately get a CLI or a command line interface to our container once it's launched. The -p here is essentially setting up publishing a port on your container to your local machine or your local host. So essentially what it's doing is it's taking host port 8888 and it is mapping it to container port 8888. Why do we need this in here? Well, one of the common use cases for the Anaconda 3 Docker image is to use it as a container to run Jupyter Notebooks. So Jupyter Notebooks run on a local host server And you typically specify a port like 8888 that Jupyter Notebook or Jupyter Lab runs on. All right, next is -v, and I alluded to this earlier when I was talking about how with virtual machines, you can set up a shared folder between your host and your guest OS. Well, you can essentially mount a directory in your container that is mapped to a folder or directory on your local machine. So that's what the -v does here. Okay, it's going to mount the current working directory, that's the pwd here, to the home directory of our container. Next, the -- name flag here, this is going to set the name of the container to be this Anaconda 3 CPSC 322. I can change this if I want. Maybe I'll do Anaconda 3 _ temp since I'm going to be deleting this container after the video. All right, so let's press enter. It says unable to find image, continuum IO / Anaconda 3 tag 2020.11 locally. So it's going to go pull that from Docker Hub. So this is really like a git pull where it's fetching some data from a remote repository. So this will take a little bit of time. We'll let it run. All right, so it looks like the pull is complete. And you can see that our prompt has now changed. Before it said gsprint Genius MacBook Pro, desktop %sign, because we're working with a Z shell here. But now I've got this root @ and then this long hash here and a £sign. So here I'll do a pwd and you can see that I'm actually operating in the root directory of my container. So this is really cool. Any command I run here at this terminal is going to execute in my container, not on my Mac. All right, so I'm gonna head over now to our Docker desktop dashboard so we can see that we have fetched this image and we have a container that is running based on this image. All right, so here's Docker desktop dashboard. So under images, I now have one local image. There it is. Here's the tag, and it is in use. You can see why this took so long to download. It's 2.71 gigs. Okay, remember, this is an image, so this is a definition that can essentially be inflated or instantiated as a Docker container to run the image. All right, so now under containers, I've got one running here, Anaconda 3 _ temp. It is based on this image. With Docker Desktop, there are a few commands that have essentially been wrapped into the GUI. So if you kind of hover over your container, you can see we've got a few here. Open in browser, CLI, stop, restart, and delete. So if you ever need to grab that command line interface, because you've lost it for some reason, right when we run it here, we've got it. You can always press this button here to get a new CLI. When you're done running your container, you can stop it, and you can also restart it. When you're done with the container completely, you can delete it. Okay, what I want to emphasize is this command here, docker run, it runs a new container from an image. So let's say I exit out of here, and then I run this command again. I'm going to take off the name here. Okay, now I've got another Docker container. This one was assigned a random name. Let's exit. Let's run it again. Okay, I've got another Docker container. Okay, so every time I run the docker run command, it's creating a new container from the same, well, from whatever image you specified here. So for us, it's the same image. Okay, so let's stop it. Let's delete this last one, delete this second to last one, and now we're left with this Anaconda 3 temp, the original one that we made. All three of those containers were nearly identical because we didn't change anything in them. So let's restart our Anaconda 3 temp. I'll hit start here. I can also run Docker start and then the name of the container from the command line. All right, so let's say we want to get a command line interface to the Anaconda 3 temp container shell. I'm just going to come over here and click this CLI button. You can see the Docker command that is used in order to give us this shell. So we can do docker exec-it if we wanted to launch this command line interface from the command line. All right, so now in here, we essentially have a shell to an Anaconda 3 Python environment. So let's try Python -- version, and we'll see that this is running Python 3.8.5. So I can launch Python, and now I have an interactive Python terminal where, let's say I want to print out hello world. Okay, so if you are following along and you do this, you'll be running the exact same version of Python and all of its dependencies included in the Anaconda 3 Python distribution as I am. There won't be any discrepancies. It'll run exactly the same. All right, so the next thing I want to show you is how you can launch Jupyter Notebook or Jupyter Lab from your Anaconda 3 container. So recall earlier I said that we needed to have our port 8888 published on our host and our container machine so that we can open up Jupyter Lab in a browser on our local machine that is tied or running in our container. So let me show you how you can do this. So I've got some notes here on how to do this. So launch Jupyter Lab using the container. So in the container CLI, which we have open, we're going to run this command to launch Jupyter Lab. And if you'd rather launch Jupyter Notebook, then just replace lab with notebook. And then do --IP. This is our local host. Here's the port to launch it on. Launch it without a browser, allowing root access, and setting the notebook directory to be the home directory. Okay, so this is, I'll note, the home directory of the container, which we have set up to be tied to our Anaconda 3 temp directory we made on our local machine. Okay, so like normal, we're going to be prompted to copy and paste this URL into our browser in order to access Jupyter Lab. So I'll do this. All right, so this looks like it's running locally on our machine, and it is, except that this port is tied to a server listing on port 888 on our container. So when we run, say, some Python code in here, we're going to be running that same Python 3.8.5 that's running in the container. So let's try it. Let's do a new notebook, and I'll just print out hello world. Okay, so I run it, prints out hello world. Fantastic. Let's print out another one just for fun, so it's different than what we did at the command line with interactive Python. Okay, so I'm going to rename this. I'll just call it testnotebook.ipynb, and this is saved in the root directory that Jupyter Lab was launched to be in. So its current working directory is actually, if we go back to our command, it's actually, where did it go? Right here, the home directory. And recall the home directory, when we created our container, is mounted or tied to our present working directory that we ran our docker run command in. So if I head over to my other terminal here, Anaconda 3 temp, and I do an ls, then I see right there testnotebook.ipynb. How cool is that? All right, I only have one more thing that I want to show in this video, And that is how you can get an IDE like VS Code connected to your container. Because sometimes we like to write our code using terminal editors or command line editors like Vim or Emacs. And sometimes we like to write our code using a graphical user interface like an IDE or integrated development environment. So let me show you how you can do that. So let's say you have VS Code installed on your machine. If you don't have it installed, you can go to this page, code.visualstudio.com/download, and download VS Code for your platform. Now, if you've never worked with VS Code before, I would encourage you to try it out. It's a really lightweight editor that is becoming increasingly popular, and it has a lot of extensions that you can install into VS Code to get some really advanced functionality. In fact, in order to run VS Code on our local machine, like my Mac, and connect it to our container so that we can use that Anaconda 3 Python distribution inside of it, we're going to have to install an extension. All right, so I'm going to launch VS Code inside of my Anaconda 3 temp folder. All right, so what I'm going to do in here is I'm going to go to this bottom icon here, which represents the extensions for VS Code. And if you haven't already installed the Python extension, I highly encourage you to install it. All right, what we want to do is we want to install the remote containers extension. So it says open any folder or repository inside a Docker container and take advantage of Visual Studio Code. You can read more of a description about it here. All right, I'm going to click install. And just like that, we've installed the remote containers extension, which, if you saw, gave us this little green status bar icon down here in the bottom of VS Code that says open a remote window. So we're going to click this now, and we have all of these different remote containers extension options. We want this one attached to a running container. So remember, if you have a Docker Desktop Dashboard open, you can click on containers and see all of your containers that are currently running. You can connect to any of these containers from VS Code once you've installed that remote containers extension. So I want to connect to this one so I can use that Python 3.8.5 installation that's inside of this container. All right, so I'm going to click. I'm going to do attach to running container. VS Code is going to go see, okay, what containers does your Docker daemon have running? Anaconda 3 temp, perfect. It's going to launch a new window. You can see in the bottom left-hand corner, that nice kind of green remote containers extension status bar icon is saying, okay, here's the progress. We're opening the remote, and bam, we're connected to this container, Continuum IO Anaconda 3 2020.11. You'll occasionally get these little pop-ups saying your service running on this and this is available. Just ignore that. Okay, now what we want to do is we want to open a folder in this container. Namely, we want to open that home directory in the container. So click open folder. We'll do /home. There it is. Hit OK. And now what's really cool is our home directory in our container is the current working directory in VS Code. All right, so when you launch VS Code, it may prompt you to select your Python interpreter. Sometimes it just pops right up. You can see it down here in my status bar. It says select Python interpreter. So if you click that, or Command-Shift-P will open the palette, the command palette in VS Code. If you're on Windows, Control-Shift-P, and you can always just type Python select interpreter to bring that up. Okay, so the Python interpreter that you want to choose is this one right here, the 3.8.5. This is the Python interpreter inside the container for Python 3. All right, so let's test this out. I'm going to make a little main.py, and I'll print hello world for the third time. And if I run this, hit my little play button up here, okay, I see hello world, and I'll just make sure that my Python here is Python 3.8.5. So this is not the Python installed on my Mac. This is the Python that's included in the Anaconda 3 image that we've created our container to run based on. All right, when you're done working with this remote connection, you can just come down to the bottom here, click on this green icon, and choose Close Remote Connection, and that will remove the connection from VS Code to that container. Well, hopefully you learned a lot in this video. We covered a lot from the basics of what Docker is and how you can compare it to working with a virtual machine, to actually installing Docker, installing Visual Studio Code, setting up an image and a container. Ooh, I have so many things open. Setting up the Continuum IO Anaconda 3 image by pulling it from Docker Hub, and then inflating a few containers from that image, running them, and then connecting to that image with graphical user interfaces like Jupyter Lab and VS Code, and just having straight command line access to it via the shell. All right, that's it. Thanks for watching.